Hello, everyone, and thank you for joining the Thomas Expert Series. We're going to get started in just a moment. In the meantime, I want to make sure that everyone has their microphone muted, which it already looks like ours. So perfect. Thank you very much for that. This expert series will be recorded and placed on demand, so please let your colleagues know how much you enjoyed the presentation today. To get everyone a little familiar with the chat, where is everyone tuning in from? I'm in New Jersey. Michael, where are you at?
Houston, Texas.
Texas. We got Georgia in the chat, Philly in the chat, North Carolina, another Jersey, North Carolina again. San Francisco, Dallas, Jersey, Phoenix.
Dallas. It's like Houston, but not as nice.
Georgia, Seattle. Cool. All right, I'm going to go ahead and turn it over to Michael here today to talk about getting the most out of automation.
All right, let me screen share here. I'm going to pull this in front of my camera. All right, how does that look?
Perfect.
So on the high level, what we wanted to get together and talk about was the proliferation of automation in labs in general, with a focus on clinical labs, but also talking about how automation fits into non-clinical labs and in general workflow optimization in order to, as the title suggests, get the most out of your automation and your potential automation. 10 seconds on myself and Jake. My name is Michael. I've been in this space for 20 years. I'm over 40 now. I blinked and that happened. I started off with analytical chemistry, automated cell biology, went over to a robotics vendor for a number of years, then automated cell imaging. We've been around the block quite a few times with quite a few scars to show for it. But the last 20 years has been based around identifying, communicating, and addressing problems and solutions through automation. And Jake Clark, I'll speak to him. He's our general manager. He's been working with me for a number of years. We started working together during the heat of COVID, high throughput process engineering, process optimization, and incorporating lab automation into a very primitive lab. He also has quite a few scars and quite a few, watching the sunrise from 3 consecutive shifts of working and seeing the sun come out the window. He's been around the block as well. The nature of what we do in science changes. So the problem that we're trying to address isn't an individual problem, and it isn't solved with a specific solution. It's an evolving problem, and as technology grows to meet those problems, the solution is evolving. What we're able to do, and keeping it limited to the scope of this talk, we're going to talk about lab automation and kind of keep it focused on there. There's a lot of subtopics we can go into. What we've been seeing post-COVID over the last year, 2 years, has been a consolidation and increase of sample volumes or processing volumes, either in a given lab or in a research environment. And just to pause a second, are you guys still able to hear me? Is this still coming through? Okay, just checking. We're seeing, especially on the coasts, we're seeing a change and a strengthening of regulatory requirements. A lot of either how things are reported, resulted, paid, reimbursed, the tightness of the ISO environments that labs are ran in, and the documentation that goes around those operations. We see that changing and getting significantly more tighter. In short, the competitive pressure, what happened during COVID is a very rapid increase in what we'll call capacity. So the national capacity to process samples and the capacity for labs to run, whether it's a clinical lab or a research lab or a pharmaceutical lab, to run testing took a step function forward. So the supply of capacity is higher than it's ever been, or pretty close to where it was at COVID, which is making people hungry to try to keep is greater than it's ever been. The demand for turnaround time, as competitive pressure increases, people get a lot pickier, and they're asking for faster turnaround time and more predictable TATs turnaround times. And as people are transitioning to work remote, work in the office, their expectations on work-life balance and quality of work life is high. There's a record turnover right now. People with skills are in demand, and employee retention is a huge unspoken piece and a benefit of lab automation. And the other strange one that hit us out of left field was multi-site collaborations. We've got groups that are in San Diego, San Francisco, and Boston. And they laugh and they chuckle and they say, wouldn't it be nice if we could run one test in 3 different places and get the same result? Binary assays, positive or negative, that one's easy to hit, but on more qualitative assays, you'd be surprised on the site-to-site variability, especially when you're doing things by hand. And again, we're focusing on one relatively small piece of the lab, but for these particular problems, these particular evolving problems, it's the question with the known punchline is how do we get ahead of those? Our piece of that solution is through laboratory automation. And what do we mean by that? We mean plate-based, or SBS, which is now SLAS standard automation. There is more industrial automation. There's automated sample processors that are more in a regulated clinical environment. There is full automation with 6-axis arms. What we focus on tend to be the type of products and solutions you'd see at the SLAS conference. The problems that they're trying to address are usually solvable within 3 months. The similar characteristics they share, they all have some sort of traceability, reproducibility. They're craving some sort of walkaway time, user safety, and scalability. Those are the common goals that we see from a traditionally manual or hand-run lab to what we'll call the first steps in automation, which is lab automation. They tend to be validatable, and there tends to be a high focus on the cost per sample awareness, and that's inclusive of, and we'll get into this, that's inclusive of what happens within the scope of the lab. There's logistics and other pieces to that, but we'll stay focused on what's in the lab. Are you guys still tracking? Is that still making sense?
Yep.
Okay. We'll pull up the chat here too. What I'd like to do is, if you guys have questions, you can throw them up in the chat, or you can just turn on your microphone and speak up. This will flow as a one-way presentation, but it would flow even better if you guys interrupted and asked questions and talked. So starting with traceability, and I expect this to be very, very plain, very boring, very expected. The ask of tracing every single step, every single time with timestamps and everything, having referenceable log files, documented files for every step that was made, having some pre-prescribed error handling. If there's no sample in the tube, what do you do? If the tip isn't working properly, what do you do? If there's a clog, what do you do? What is the semi-automated and semi-expected response for common errors? And we see the laboratory information systems, or the LIS system integrations. So, the first the first expectation people have with automation is they can push a button, they can write a check, and their throughput will go up and their costs will go down. That happens with time, but that's usually a mismanaged expectation from people with, with their eyes on the pocketbooks versus operational experience in a lab. And I'm rambling a little bit, but sticking to traceability. Before you can control things, a major piece of making changes to systems is to be able to consistently observe those systems. We talk about site-to-site variations. We talk about user-to-user variations, even hour-to-hour variations from a single user. That traceability we see as a fundamental bedrock for automation. As without it, it's hard to tell how things change over time. We often get pulled into discussions around the difference and the different understanding between repeatability and reproducibility. And lab automation, it does an excellent job at reproducibility and repeatability. The difference mainly being an individual rerunning a test with extremely few variables changing, most notably the time that a particular test is run, and reproducibility. That's if I do a process, document to process, hand the document over to somebody, can they reproduce not just my results, but my test and my process in a predictable way? Lab automation by its nature, it's developed on a piece of equipment, and then the execution of that equipment doesn't change the commands of the robot. So the probability of reproducibility on lab automation is orders of magnitude greater than that of human to human. As the user to user, the shift to shift, and most extreme, the lab to lab differences that we have seen in a number of tests have been extreme. Squeezing those improvements out of lab automation after traceability is the second lowest hanging fruit. It's very easy to do, and the results are very dramatic. And I'll keep beating on this one. The ability to reproduce work is fundamental. It's foundational. It's critically important. We often see white papers that are published without a peer check or without the ability to the reproducibility of data. There's interesting statistics out there that show, the percentage of data that's presented currently is less reproducible than in the history of recorded science. It's a little scary. For the lack of a better meme picture, this is lab walkaway. The expectation is set that you can push a button, you can walk away, and come back 6 hours later, and you've got money in your checking account from your customers sending you funds for the results. What walkaway means to a bench scientist is you have the ability to work on, in most cases, assay optimization, assay development, documenting the processes that you're working on, confirming that the steps that you're taking, the environment that you're working on is appropriately maintained. That's a big one. People tend to cut corners when they're busy. People cut corners surprisingly on safety. We see a lot of people without enough time to handle their processes, unsafely opening and manipulating patient samples and containers, and sharps are a big one. Handling waste is a big one. The idea of offering an option to your staff of walkaway time has been hugely beneficial when you compare it to the grind and the hustle of a fully manual clinical lab. So squeezing walkaway time out of automation, that's a secondary benefit of it. It usually isn't what people are expecting, but it's a huge benefit. The mental health side of it, the idea of having a piece of equipment to do your job for you. So you tell the robot what to do, and the robot does the heavy lifting and the repetitive pipetting, as an example. That's huge for staff retention and for mental health. It's a lot of fun to transfer hundreds of samples once, but you do that shift after shift after shift, either in a research environment or a clinical environment, for those of you who know, you know, it's hard to communicate how numbing that gets. That walkaway time with automation, I'm assuming it's self-evident for the people on this call, but it's a huge, hard to measure benefit, hard to quantify benefit. We have high expectations of process optimization. Our history has found that the speed increase is expected. The reduction of reagent cost as the reproducibility of extreme low volume transfers of expensive reagents, think master mix and probes and primers. If you can reduce those down, as those are one of the more expensive reagents in the test, if you can reduce those down 20%, 50%, 80%, your heavy cost per sample, the biggest piece of that cost per sample pie being reagents in many cases, that can be reduced 80%. We've seen people take off-the-shelf kits and do stabilized process optimization testing and found that they can amplify effectively at significantly lower volumes. We do a lot of work in we have a very strong relationship with Thomas Scientific on optimized consumables for automation. As you'd expect, running 96 samples at a time in a 96 well plate, lower reaction volumes, lower sample volumes, lower reagent volumes, higher sample density. The ability to process 100 samples in the time it takes you to process one is an extreme comparison, but one we see often. Matching appropriate consumables with your process, you on a per sample basis save a significant amount of resources. And when you look at the cost for a bad data point, we don't get into it here, but a false positive and a false negative, those get very expensive very quickly. People get very grouchy with those. And in R&D, you can set yourself up for a white rabbit. You create an interesting point that shouldn't have existed in R&D, and then you go and you try to reproduce it as it was manual. The repeatability and the reproducibility is not there. It's a very expensive, unexpected piece that people don't talk about. The double-edged sword that we bring up with process optimization is, people see what is done relatively quickly from a manual lab to an automation lab, and they see the gains. They see within a month you can get 20, 30% cost reduction. And they look for that the second month and the third month and the fourth month. Similar to quality, process optimization never has a goal. Very rarely is there a tangible, we're looking for a 40% improvement or reduction in our costs. Usually what it is, hey guys, we want to be cheaper per sample. Let's figure out what corners we can cut. We cut them. When that's presented and that's satisfied, that's a death march. They ask for it again and again and again, and pretty soon they dig into quality issues and employee retention issues. So, defining your goals with process optimization prior to heading down that path usually yields a more discrete packet of success versus a continual effort of what we'll call diminishing returns on process optimization. User safety. I've seen labs, I've seen groups where people, and I'm sure you guys have as well, where people are popping open hundreds and thousands of vacutainers filled with human blood. And as they pop, you can see the stabilized blood, all the particulates splashing all over the hoods, getting all over the place, getting all over the gloves, aerosolizing. Just the blood itself on vacutainers alone is, that keeps people up at night. What automation lets you do, from decapping to recapping to transfers to disposal to waste, there's less manual sample manipulation as expected. That piece to this is, there's not a cost to it until somebody gets hurt, but it's a significantly reduced cost in the environmental health and safety qualifications of the lab when samples aren't open and manipulated by people. The nature of most lab automation, from amplification unit like a QuantStudio or a liquid handler or an automated centrifuge is the envelope that the samples are being handled is enclosed. That enclosure offers a very significant physical barrier between the technicians walking around the lab and the samples themselves. Similar to a safety hood, but a safety hood that people tend not to put their arms in, as the arm is a robotic manipulator. That's a huge safety piece to this. The robots themselves, they follow a code. Literally, that code is extremely predictable. In most cases, it'll do exactly what it did last time in a very predictable way. It means very limited deviations. You know, robots aren't going to leave their enclosure. Robots aren't going to turn left when they're turning right. So that is in opposition to a technician sitting at a hood with their elbows up, manipulating samples. This is a scalability guideline and setting expectations. We understand, I'll get to the end first and then we'll backtrack a bit. Upstream and downstream vary quite a bit, but what you can expect out of liquid handlers or traditional lab automation, somewhere in the order of 8,000 samples, 8,000 transfers per shift. So if you're doing a tube to plate sample transfer, you can realistically expect to get 8,000 or 9,000 of those motions done in an 8-hour shift. So roughly 1,000 per hour, without using multi-channel heads or without using extreme automation. It's a very realistic expectation to be able to get 8,000 or 9,000 transfers or 8,000 or 9,000 actions done per system per shift. Now you can use a 96 well plate, you can use a 384 well plate, you can use multi-dispensing characteristics on the system. You can significantly improve this, orders of magnitude improve this, but an excellent expectation benchmark is 8,000 samples per shift. We were easily able to achieve that in a COVID lab and clinical environments across the country. With that, that's significantly more than what a human can handle with a 8-channel pipetter, or even more so with the 1-channel pipetter. You've got to keep your upstream and your downstream in mind. As we talked about in the beginning, as I mentioned in the beginning, we're limiting this conversation to one piece of lab operations, being the lab automation. You need to feed the beast. You need your FedEx guys to drop off your samples. You need your R&D team to take the data that you generate and make meaningful decisions post data generation. Just because you can generate 8,000 motions or ideally 8,000 results in one shift doesn't mean you have the ability to feed that or the ability to handle those data once those come off. And we see a log jam of things that you don't expect. For an example, we didn't expect the need to have such an immense post-sample processing storage capacity for samples that needed physical storage for 14 days after they were in. And we're running, and it didn't seem like a big deal until the first shift we ran 8,000 samples, and the second shift we ran 8,000 samples, and the third shift, and all of a sudden we've got 30,000 samples in a 24-hour period that all need to go into a large refrigerator. And that presents its own demand on process optimization. Storing samples in automation-friendly secondary containers. So instead of storing samples in their primary collection container, we were transferring them into deep 96 well plates. That allowed for a much denser sample storage in the situation you needed to rerun a sample. That enabled us to do it without increasing the footprint of the lab. I say that as the iterative nature of a project of turning on lab automation in a standard lab will present problems that didn't exist prior to automation, often for better, sometimes for worse. All labs, all research environments, all development environments, all we'll call them production environments, they all have different levels of validation. In most cases, most people in most labs are using equipment, solutions, chemistry, processes that are extremely similar or identical to a process that's been ran in the past. So a lot of the verification and validation, are you guys still tracking? Are you still able to hear me?
We're still here.
Okay, just checking. It'd be it'd be really sad if I lost you 10 minutes ago. But the validation and verification that we see in labs, it often is extremely predictable. Even more so when you're using a robot that doesn't need to go through training like a new lab technician does. The installation and operational qualifications, we call them IQ and OQ, and they precede performance qualifications. Those are prescribable as far as the amount of effort that goes into them. Performance qualifications, is this working chemically and in an environment in the way that we're expecting and our customers will trust. That's application by application specific. Whereas the installation and the operation qualifications follow a pretty tight and pretty consistent installation procedure. Standards in clinical labs, the same thing. If you have a requirement to test positives and negatives and matrix match the positives and result on cross-contamination, those known processes for validation usually is a matter of referencing and deploying an existing protocol. It rarely is modifying something that currently exists. But in that case, it's a relatively easy effort to do. And extremely rarely, you guys are doing something completely out of the box. And that requires establishing a new validation protocol. But in most cases, most applications can be prescribed within 15% of the effort required to run through a full set of validation. Even to the point where the documented protocols that other groups have used that are publicly available can be used as a scaffold to base yours off of. You rarely have to reinvent the wheel with validation, if that makes sense. This one's interesting, and I'm going to further narrow down the scope of what we're trying to talk about. So the cost per sample, this is similar to process optimization. This is a death march. You'll walk a certain distance, and then you'll be expected to walk a certain distance more and more and more. And eventually, the return that you're able to deliver will be similar to what you're able to deliver the week prior. The economics of scale are extreme, from very low volumes to medium and medium high volumes. That tapers off application specifically very aggressively as you get into extreme volumes. Where you're able to cut costs significantly, as mentioned, the materials used, whether they're the consumables or the reusables on the deck of a liquid handling platform, the chemistry, primarily done through reduction in chemistry volumes. The human cost, and this is a human cost per sample, not necessarily the reduction of people, but the ability of an individual, instead of handling a single sample at a time, the cost savings comes as people can handle 100 or multiple hundreds of samples at a time. What we've seen, which has surprised us, we've seen automated labs, what they call fully automated labs with traditional accessioning. So there still is a regulatory requirement that each of the samples are manually checked for patient information to confirm that patient information matches what's in the LIS system. And there's a manual aspect in a lot of environments, whether it's checking to see if the scratch plate was set up properly, or if the cell line has unique characteristics that won't come up on an assay at the end. If some odd growth or some odd characteristic of a culture that you're running exists. Upfront sample processing still needs to take place. The sample integrity still needs to be confirmed in many cases by humans. We have not seen a lot of proliferation of automated decapping, automated image-based QC on these intermediate labs and these intermediate efforts. We start to see that on what we'll call a fully automated lab, where it's, there's some companies that will do home collection of, for an example, a fecal biopsy. And the fecal biopsy will be mailed to the facility, and the facility has a turnkey solution where you just take the box, you stick it into the end of the wall, everything is processed from accessioning to sample paperwork to sample integrity, and that gets fed onto liquid handlers and analysis systems at the end of the process. The other thing that automation is not able to handle is the overhead outside of the lab staff. You still need You still need human resources, you still need janitorial, you still need all of the pieces that go into a lab that add significant amounts of cost. The cost per sample, just on the material chemistry and the human cost within the lab. Our approach to addressing those is our only tool is a hammer. Everything kind of looks like a nail. The way that we address this is through automation. Automation can, as mentioned, handle aggressively your material cost, your chemistry cost, and the ability for humans to process more than one sample at a time. What we see as pitfalls, and we see these often, and we try to lead with these in order to temper expectations. There's a big difference between IQ, OQ, and PQ. So IQ, OQ, it's following your recipe to bake a cake. The PQ is, does your cake taste good? It tends to be subjective. It tends to be unpredictable as to the level of performance qualifications that a group or a lab wants to take their protocol. But IQ, OQ, in most cases, on most instruments, it's 24 to 48 hours. Stocking consumable. This is back to the 9,000 samples a shift. Great, we're getting all these samples. Great, we're getting all this request to fully utilize all of this equipment. But wait a second. We need 8,000 tips per shift. We need 8,000 divided by 96 plates per shift. We need seals. We need all of the non-traditional consumables. Not only do they not, in most cases, they do not match what's done manually. In many cases, the throughput is significantly higher, and labs will often understock internally enough consumables to handle their sample volume. We see this all the time. We see lot variations. As the number of data points go up and the availability of the data to be reviewed on computers or reviewed electronically, we can more precisely pull out lot variations of a lot of the reagents that groups are using. It's a big deal when you get into qualitative work. Usually, the quantitative or the binary results, the lot variation doesn't. The fluctuation in it doesn't have a major impact, but we see significantly more of it statistically when we're able to handle large sets of data. Client requests, we get oddball ones all the time. People are asking for tests that labs aren't comfortable running, or very low volume tests. They say, hey, look, we're sending you all these samples. Can you run something? Can you run a toenail fungal extraction? Can you do a handful of samples? So there's quite a few quirky client requests that labs aren't comfortable saying no to, that cause interruptions to streamline automated processes. Recently, post-COVID, we've seen a huge amount of staff turnover. We've seen people who, they want something different. They want to continue working from home. They want more pay. They want, different. They think the grass is greener. So we're seeing double digits, staff turnover rate, where normally we saw 5% annually. And one of the big ones, I save this one for the end. It's very important to talk about. We see the lack of in-house automation expert. So if you're critically dependent on equipment that you don't understand, it's a matter of time before you get burnt by relying on outsiders to help. Having some sort of point of contact, some sort of automation super user expert, not a guru, but some key person that has their finger on the pulse of the automated systems in the lab. The labs that have these have been notably and measurably more successful than the ones that don't. Most equipment, quant studios are complicated and they're expensive and they need to be handled appropriately. Quant studios, I'm just picking them as an example. You think you just walk up and you stick a plate in there and you push a button and you generate a result, but that only works until it doesn't. And when it doesn't work, who do you call? How do you fix it? The idea of having an in-house person to oversee this equipment is to preemptively get ahead of that, to analyze the data before it fails and say, hey, this is trending in a direction that we're going to get we have a high probability of this thing failing in a month. Let's do something preemptively, or schedule service, or get ahead of our problems ahead of time. That in-house automation individual has been notably valued in labs. I'm circling around, trying to keep this focused on lab automation in general, but just sending a kind of a lightning bolt down to the ground as to what we do at Nugget Scientific. I'm sure it's implied. If it's not, we service, we repair, we upgrade liquid handlers. We sell them. We've got a number of them in stock. We do programming and training and assay optimization and process optimization around sample handlers, liquid handlers. We focus on Hamilton stars and the consumables that go on them, the programming that goes around them, the support and the maintenance. You know, we're a turnkey facility for those liquid handlers and in Kingfishers as well from Thermo. We won't beat on that too much. We've been doing this for a number of years. We've been in front of them for decades, and it's been through COVID and beyond. It's been a great endeavor. There's a big piece to automation that a lot of people don't talk about. That's the community of nerds that love their robots. They tend to be a similar ilk of the 3D printing crowd, but with an automation flair. There's a lot of forums, there's a lot of groups, the SLAS community, and there's a number of lab automation forums online that are taking an approach to controlling everything through Python, a programming language. There's a number of great groups out there. They can be found on LinkedIn. They can be found. This lab automation forum is a great place to start. That's a very helpful resource when trying to grow your internal capabilities. As mentioned, Jake should be on here for Q&A with me. I'm Michael Gaynor and Jake Clark. But that's the end of what I've got for the presentation. And I'd like to, it's 1:39 Central Texas time. We can turn it over for some questions if we have any.
Thanks, Michael. So before we get started with Q&A, while you guys are all typing out your questions or thinking about them, I'm going to go ahead and share my screen for just a moment. So I wanted to take a moment to show you that there is a giveaway that is running if you take the survey that is in Nugget's kiosk. There's also literature, web links, as well as videos. In here, you will also find the on-demand talk. So this talk will be on demand by tomorrow. So you'll be able to find it here as well as all of our past talks. So please be sure to check out any of those talks that interest you. And also, if you go over to the labs tab, we have stuff over here in the Thomas Center, and you can go ahead and hang out in there. So I'm going to go ahead and hand it back over to Nugget to finish us out with the Q&A.
Excellent. So how would you suggest addressing urgent problems that happen to liquid handlers off hours on weekends? So if it was manual and one technician was having a problem, you could always ask somebody else to do it. But with automation, if you're critically dependent on a piece of equipment that something happens to late at night, how we've been able to handle that in most cases is by reaching out to our clients have reached out to us. We've been able to remotely tunnel into their machine through a VPN and walk them through understanding the problem. And in most cases, the problem can be resolved remotely with phone support. And nights and weekends are tough, but being able to reach someone over the phone quickly and in most cases recover a process as it's running, so you don't lose the integrity of those data. Quick service, phone service, if necessary, getting in there the next day to fix something, but usually time is working against you. So the quicker you can get someone to help, the better. At Michael, with all the pros to moving lab processes to an automated platform, how can we start the process? What information do you need to know to get labs up and running? Where we start in most cases is with a chemistry or a protocol. So if you're trying to run a particular extraction, for example, You start with a protocol from the chemistry vendor, and you reach out to us, either telephone call or a text or an email, and say, hey, I'm trying to run this particular protocol. That allows us to put together a quick presentation and a quick solution summary and lay out the next steps. What we're able to do in most cases is, within a week, we're able to have equipment deployed and IQ/OQ passed in a lab from shipping to setup. In some cases, it takes more time than that, 2 weeks, but it's a relatively quick process that usually starts with setting expectations of what you're trying to automate. And let's see, another question. Where do you see the most common low-hanging fruit for process streamlining in clinical labs? For process, again, people are starting with single tubes and they're going to 96 well plates, call it 100 samples at a time. The cost per reagents when you're dealing with a tenth of the volume exists. If you're sensitive to the cost per sample, the time it takes to run samples is usually reduced greatly as you can parallel process and run 100 of them at a time, but the cost for the staff is reduced. And the space and the equipment itself, it seems like a CapEx purchase, but compared to the alternative of having dozens and dozens of hoods and individuals, it's much more efficient.
Michael, I had a question. Do you work with groups outside of the US or just US based?
So, we love Canada. We love Mexico. We love Europe. We don't deploy our service team out internationally, but we always pick up the phone, and in a lot of cases we're able to help, or at least point them in the right direction of someone who can help internationally. We don't ever turn them away, but there's some countries that are difficult to get to, work visas and what have you. But
Understood. Thank you.
Yeah,
Appreciate
no
it.
problem. What else we got? Anybody else? Going once, going twice.
No, doesn't look like anyone else.
Okay.
All right, thank you so much for joining us today. I hope you all have a great rest of your day, and thank you, Michael, for joining us today.
Anytime. All right. Take care, guys.